Today, what I'm going to show you is an app which I think is invaluable in the field. It is the Danfoss Refrigerant Tools app. Now, when you get the Danfoss Refrigerant Tools app, it will open up and there'll be a link just here for it. Download it and it will come up with your various tools. You'll see at the bottom, you'll have the refrigerant slider, which is one of the main ones. Then tools, products, and settings. What I would like to show you first of all is, before we go on to the refrigerant slider, is the other tools that you have in there. Now, there are some various good tools on there, but there's a couple of ones I really would like to focus on other than the refrigerant slider. These ones here, the Troubleshooter, will help you understand your various problems inside a system, and you can click on the various items and talk about the various bits, and it will even come up with that the compressor is, for example, too hot, and it will give you some links: insufficient liquid in the evaporator, and then it will give you some possible scenarios or symptoms that we need to diagnose and then rectify. But if we go back to the tools, in this area here we have the tools. This magnetic tool, I believe, is very valuable in what it does and the technology behind it. Now, this magnetic tool actually senses magnetic fields of other devices. So you could hold it against your solenoid valve, and that solenoid valve will then give off the magnetic field, and this circle will start spinning. I'm going to try and see if I can get another mobile phone next to it to prove that it will start spinning. But also you'll see you can put the advanced mode on, turn it on and off. It's very simple. But if I turn it on and I hold this mobile phone, there we go. There's my other mobile phone. This mobile phone here is giving off a magnetic field, and you can see the magnetic field flux change. It's just loading up my phone. And you can see the magnetic flux here change, and it picks it up. Now, if it gets strong enough, or if I put it next to it or this way, now the circle starts spinning. That's only because it's picking up the magnetic field. So if I put it this way, it doesn't do it, but if I turn it this way and put it here, it picks up the magnetic field from this mobile phone. This mobile phone's picking up the magnetic field, and you can see the DC magnetic field climbing, and only when it gets to a certain amount will the circle start spinning. And you'll still also have the option of volume on there. If I turn my volume up, you'll be able to hear the volume. So that's a really good device, because you can place it on top of your magnetic coil of your solenoid, and if it's on and it's creating a magnetic field, this will spin and therefore be able to tell you if the actual magnet is working or the electromagnet in the solenoid is working. And if there's a problem with the solenoid itself, then it's not the electromagnetic device or the electromagnetic solenoid on top. It might be the actual valve. There's our magnetic tool. We've also had, as I said, the Troubleshooter, which is very helpful, the magnetic tool, and now your SuperHeat tuner. Now, what Danfoss has done here is been able to create and help you understand how to tune your TX and turn in your adjustment screw, or in or out your adjustment screw on your thermostatic expansion valve. So we can put in our room temperature. Let's just put in our room temperature of 3 degrees C. Yeah, so we're going to go for a fridge. We're going to choose here, and this is a good thing that Danfoss has also given us not only their own brand, but other brands as well, which is very helpful. They're very good at doing this sort of thing. And I'm going to go with a T2. So I've now selected a T2, and I'm going to choose 134A. So here I've set it as a fridge for a room temperature at 3 degrees, a Danfoss T2 type TX, and refrigerant 134A. Then I'm going to go next. And now it's going to ask me to take my readings. And this is where we need to take our readings. So we're going to talk about the evaporation temperature and pressure. So let's have a look, and let's say our evaporation pressure was 150 kPa, which I know is an absolute. So let's change that. Let's make it 250, because 150 kPa gauge is -5 or -4, -5. So 250 kPa absolute, because notice it says absolute here, is -4.28 degrees. Then we're going to talk about our suction outlet temperature, the temperature at the bulb. Now, we would normally want about 5 or 6K superheat, so it should be about +2 here, but I'm going to put it down as 5 degrees C, so that we're getting a lot of superheat on it. And here it says the recommended superheat, I said between 5 and 6K. We're saying it's, right now, the recommended is 5K. This is what Danfoss said. I said 5 to 6. Danfoss said 5K. But the current superheat at the moment is 9.3. What it asks there is saying that I've put in my pressure of my system, or saturated suction pressure. Therefore, it's given me the saturated evaporating temperature, or saturated suction temperature. Then I've taken the temperature at the bulb or on the suction line, and it's worked out the superheat that it should be recommended, as I said, between 5 and 6K. They're saying 5.1K for this setting. And the current superheat is 9.3K, which is the difference between -4.28 and +5. So then I'm going to hit next. And this is what it tells it to do. It tells me that the superheat is 4.2K too high, and that I need to adjust the spring, and therefore the screw that adjusts that spring, I need to change it anti-clockwise, or they could say it counterclockwise, CCW, and turn it 0.64 turns, so 0.64 of a full turn. And you want to get down to that 4.2K, because we are out by a difference of just over 4K. Just over 4K, and that's what they've said here. Superheat is 4.2K too high. We need to now adjust it back and turn it counterclockwise. In other words, we've got too much superheat, not enough liquid in the evaporator. We need to open up the valve and let a little bit more liquid back. Now, obviously, this is not 100% accurate, but it's a good, helpful tool. Because let's change it back around and go previous, and I'm going to change my superheat to -3. Actually, we'll go -2. Yeah, -2. Right? Check value, check value. So this current, we're saying that we recommended superheat now is still 5.1, but we've got 2.3. So we go next, check the measurements are put in correctly, continue anyway. Now it's saying go the other way, because we've got, our superheat is too low. We're meant to have 5.1K, we've only got 2.3K. 5.1 is what we're meant to be. As I said, 5 to 6K superheat. That's my rule of thumb for a fridge. And 2.3K is too low. So we need to then turn in clockwise the screw to tension up the spring. And we're meant to do it just under half a turn to bring it up by another 2.8K up to 5.1. And there is our superheat setting. And notice there it says the adjustment requires 6.38 minutes to take effect. So it's actually telling you to wait, and you can click a timer and the timer counts down, and then you'll take your measurements again. All this is on your phone, and this is what Danfoss is helping us do. So we're going to go back to our tools. So we talked about our Troubleshooter, our magnetic tool, and our superheat tuner. Podcasts. Some of these podcasts, if people are into listening to podcasts, obviously I'm not on the internet right now because I don't want phone calls coming through, but your podcasts on there, so many different podcasts, and if you're into listening to those sort of podcasts, very, very valuable product. But what we're going to do is go back to our refrigerant slider. This tool is everything that we need. It is this. Yeah, this is a PT chart, pressure temperature conversion chart, and it's got all the various refrigerants at the top. Okay, and you've got 1, 2, 3, 4, 5, 6, 7, 14 refrigerants on this page, and all these different numbers. All this is in here. And what we do is I'm going to show you how to set this up so you're all ready to go. Now, the top red corner, or top right corner with the red button, click on that, and you can actually adjust what pressures you read in. I like going metric, so I'm normally using kPa. The UK might use bar, other people might use PSI, but these are our pressures for it. So I'm set at kPa. Then what we want to do is make sure that we're using either our various temperatures. Most countries use degrees C, some countries use Fahrenheit, and distance unit, meter, some people use feet. And then we have our refrigerant slider. Now, for me, later on, and when we do our lessons on refrigerants, this is pretty important between AR4 and AR5. AR4 is Assessment Report 4, which was carried out in 2007 by the IPCC, the International Panel or Intergovernmental Panel for Climate Change, the IPCC. AR4 was done in 2007. AR5 was carried out in 2014. The IPCC have just done a report or started doing investigations for a new report in 2021. The results are yet to come out, and that will be Assessment Report 6. We can do reverse the slider back and forth, so that reverse the slider will change it from high at the top, low at the bottom, or low at the top, high at the bottom. It depends on how you want to read it. Some people like having it so that it's high at the top, low at the bottom, which makes sense. Once we've done our pressures, we can go back on our settings, and now we're going to set up our refrigerants. What we'll do is click on this window here, and we'll come up. You'll normally see it will go all, which is all your refrigerants, and you've got this many refrigerants in there that you can use. There are so many refrigerants in there that you can use. Okay, that many. But what I do is down the right-hand side, they've got all these stars. Some of them are blank, and some of them, if you noticed, I've clicked and highlighted. That means I've made it my favorite. So these are some of the ones that I recommend students to put as their favorites: R22, R32, R134A, R290 propane, R404, R410A, and then R600A isobutane. Now, obviously, if you're working on other refrigerants such as ammonia, CO2, you can highlight these in as well, so we can just put them on. I've highlighted them on. Once you've highlighted them on, you never need, and they're the ones you're only going to ever work on, you just go to your favorites, and now you've got your list of your favorites. And you can unfavorite them, you can take them off. So I've got rid of CO2 and ammonia there. I can go back, find CO2, and I can find ammonia there. And I can put it back on, and they're back in there. So there's my list. We go straight to my favorites, and I'm going to use my top 6 or 8 refrigerants there are my favorites, which I work on. Once you've programmed that, you only ever have to go, rather than scrolling up and down, you just go straight to your favorites and pick and choose the one you want. So right now, we're working on 134A. I can click on that and change it to 404, and it changes to 404. Now, I'm going to go back to 134A because it's an isentropic refrigerant. It's a pure single refrigerant, and therefore it won't have a glide slope, so you won't have dew. When I go to 404 or 410A, you'll notice it either has dew or bubble. And that's because it has multiple component refrigerants in one refrigerant, and therefore they boil at different points. That's why it's an R4, what we call a zeotropic refrigerant. But I'm going to go back to 134A. Now, 134A, we can work either way. We talked earlier on about our pressure, temperature, substance triangle. Well, this will help us out understand that more. But before we go on to these pressures and temperatures, we're going to look at these parts down here. Notice we've got our safety group. It tells us our ASHRAE category of safety, A1, which means it's non-toxic or low toxic, and 1 means non-flammable. GWP on AR5 is 1300. If I change that to AR4, it was 1430. The ODP is 0, so it's not going to affect the ozone. And then it gives me my critical point and my boiling point at normal atmospheric pressure, minus 26. And also it gives you the colour code of what the cylinder should be coloured. And that's the very light pale blue for 134A. Lots of information. You can click on that and it will give you more stuff down here. Lot more information. Auto ignition temperatures, its triple point, critical pressure. We talked about also the oil that needs to go for it, the classification of refrigerant, the actual name, the chemical makeup. There's so much information in this tool. So we're going to go back. What we would normally do is, let's say we want to work out the pressure of the refrigerant inside a cylinder. If we know it's 134A, and we get our fixed temperature or ambient temperature of 25 degrees C, we can work out if it's pure 134A by putting our gauges on and saying if it's 564 kPa gauge, then at 25 degrees C, R134A, pure R134A, will be 564 kPa. If we have a different pressure in there, that means there could be contamination in there, such as moisture, nitrogen, other non-condensables. Or it could be a mixture of other refrigerants. Someone has, inappropriately mixed it with other refrigerants. So 134A at 25 degrees C should be 564 kPa. If you go to a 134A system, or even a 134A cylinder, and you take the temperature around that cylinder and of that cylinder, and it's 25 degrees C, the pressure of that refrigerant should be 564 kPa. If it's not, there's something else in that cylinder that's causing it not to be. So, what we're going to do is we're going to come up with some temperatures and pressures and then work out what the refrigerant is. So, if I turn around and said the temperature is minus 24 degrees C, and the pressure is 156 or close to 156 kPa, if I put in here minus 25 degrees at, we said 150, around about 150 kPa, it can't be 134A, because at minus 25 degrees C, 134A is only 5 kPa. So we've got to find a refrigerant that at minus 24, minus 25, let's say minus 24, is roughly 156 kPa. So we've got to find out our system, or our cylinder. Our system is at minus 25 and our low side is at 156 kPa. We've got to find out what refrigerant that is. So we could go minus 25, let's change our refrigerant. Let's see if it's R22. Minus 25 in there. Well, it's only 100 kPa. So it's not, we said 156. So it can't be R22 at minus 25. Our system is at minus 25. Sorry, actually minus 24. Minus 24, and it's 108 kPa. So we're saying our system's running at minus 24 and it's 108 kPa, it can't be R22 because our system's running at 156 for minus 24. So let's have a look. Let's go to another one. Let's choose 410A at minus 24. Well, that's 241. It's too high. We're saying we've got a pressure of 156. So let's go to a next one. Let's go and try, let's go and try another one. 404. Let's go 404. Minus 24. Okay, great. It's 156 kPa. So we know at minus 24, if we're getting minus 24 and it's 156 kPa on the gauges, well then it can only be R404. And the reverse is true. If I know I've got 404 and it's 156 kPa, the temperature inside the evaporator is minus 24. The refrigerant temperature inside the evaporator is minus 24. And this is really important. And this figure, this 150, is, or round about the 150, if I typed in 150 kPa in there, we're saying 150 kPa on 404 is minus 24. And that would roughly be our target temperature of the refrigerant inside the evaporator of a freezer. We can change the dew point now. So our target temperature of a refrigerant in a freezer, our freezer wants to be room temperature of minus 18. We would want a lower temperature in the evaporator, a lower temperature of the refrigerant in the evaporator, and we're saying roughly about minus 24. Minus 24 degrees C, which would be a target temperature of the refrigerant inside the evaporator, for 404 is 150 kPa. So 404 is thought of as a low temperature refrigerant, and we use it on our freezers. But here's the interesting point. If we go back to R134A, R134A is thought of as a medium temperature refrigerant, and that medium temperature refrigerant is normally used in fridges. If our target temperature for a fridge is about minus 4 degrees C, we said minus 24 for a freezer, target temperature of the refrigerant, well, we want minus 4 in a fridge. So if I put in 150 kPa, again, look, minus 4 is the temperature that we want roughly inside the refrigerant temperature of the refrigerant inside the evaporator, and we're getting 150 kPa on 134A. So if you remember 150 kPa on 134A, or 150 kPa on 404, 150 kPa on 404 and 150 kPa on 134A will give us our target temperatures of the refrigerant inside the evaporator. So we want to remember 150 kPa for 404 on a freezer will give us our target temperature of the refrigerant inside the evaporator. Whereas if we go for 134A and again put in 150 kPa on 134A will give us our target temperature of our refrigerant in our evaporator. So that 150 kPa on 134A and 150 kPa on 404 is our target temperatures for our fridge and for our freezer. So remember that 150 kPa. And this is very important. And this Danfoss app, really does help you out. You can do it manually. You can actually slide the slider up manually, up and down the sides. Yeah. Which is good. But I just quickly do it in temp by typing it in. See, the good thing also is this area here, each time I change my refrigerant, I get my various levels. You can see here the GWP figure at AR4 for 404 is 3,922, whereas our 134A was for 1,430. Quite a lot of the information for diagnosing a refrigeration system is in this Danfoss app. And I must give credit to Danfoss for doing such a great job in this tool. It's so flexible, so adaptable. You can use it on lots of different things. The magnetic tool is what I use. The SuperHeat tuner, I do double check. The troubleshooting is great, especially for people starting out or apprentices. This whole tool is so good. And you can also get products and everything. You can actually look at the stuff, but because I'm not on the internet right now, because I don't want phone calls or messages coming in, it's all there. Settings are there. You can go back in. It's so good. And I have to say, thanks to Danfoss for making this. It's such a good tool to use for learning and out on the field. So for those students who are interested in learning refrigeration, I recommend you download the tool. Here's the link for the tool, and also probably a QR code I'll put here. There's the QR code to get it. Get it on your Android phone or iPhone. Very good tool. I recommend this to everyone and get to know it, how to use it. It helps out so much. And thank you for listening and paying attention. Hopefully you've learned some bits from this. If you have any questions, please put comments at the bottom and I'll be here to help out.